Right. Okay. Welcome, folks. We are looking at question 3 right now, and we are looking at particular question 3.1. And I want to find the coordinates of M. But first, in the diagram, S has the coordinates 0 and minus 16. Q has the coordinates those. Okay. And are the vertices of triangle SQL, triangle SQL. Having SQ perpendicular to having LQ perpendicular to SQ. So here is LQ is perpendicular to SQ. SL and SQ are produced to points R and M respectively. So they're produced to points R and M respectively. So in other words, we are effectively saying, um, right. So SL is produced to R. So in other words, here is SL and SL is produced. So in other words, it's further extended to the points R. But also we have that SQ. Here is S and here is Q. Is also produced to the point M. So here is SQ and is produced to the point M, respectively, such that RM and LQ are parallel. So we have that RM is parallel to LQ. Now, as M produced cuts the x-axis at N. Now, QM is equal to MN. So we have that QM is equal to MN. Okay, they marked equal here. T and P are the y-intercepts of R and M respectively. So in other words, we have that P is obviously the y-intercept, but also T is also the y-intercept. Okay, and the y-intercepts of RM and LQ respectively. Okay, that is very clear. All right, we are so good. Let's continue now to answer the question. Let me clean up a little bit diagram so that we have a tidy diagram to deal with. Otherwise, we shall have a diagram that's a little bit untidy. So we are doing very, very well. Okay, what do we want to do now? What we want to do now is to actually calculate the coordinates of M, and here is the point M, and clearly M is the midpoint. So the question for the formula for the midpoint, what is the formula for the midpoint? Right, so the midpoint is found as follows. So the midpoint is found like this. So we have x1 plus x2 out of 2, but we also have y1 plus y2 out of 2, like this. Right, so what do we do right now? Right, so we have that obviously it's M, so we can choose this one to be x1, y1, and we can choose this one to be x2, y2. So that now M is x1, which is 4. What is x2? It is actually 8. You divide it by 2. What is y1? It's minus 8. What is y2? It is 0 divided by 2. So now this is therefore M with the coordinates 4 by 8 plus 8. You add them, you get 12. You divide by 2, it becomes 6, and minus 8 divided by 2 is exactly minus 4. So that is exactly what we get over there. Right, we continue now to look at the next one, and we look at the answer to 3.2. We want to calculate now the coordinates, or rather the gradient of an S. Here is N, and here is S. Want to find the gradient. The gradient. So the gradient is actually very, very straightforward. How do we find the gradient? So the gradient of an S it is exactly y2 minus y1 x2 minus x1. Right, so if you're looking at the 2 points N and S, right, so this is what we're gonna do. Right, so we're gonna have this one here, S. What is S? Right, this one is x1, you can call it x1, y1. So you have therefore y2, which is 0 minus y1, which is exactly minus 16. Okay, we divide everything by x2, and here's x2 here, which is exactly 8 minus x1, which is 0. And therefore, this is 2. So the grade of NS equals 2. Okay. We are doing so far so good. The next thing now, we're going to do 3.3. Show that the equation of the line LQ is given by that one. So if you look at LQ, here is L, and here is Q. Want to find the equation. So to find the equation of the line LQ, it's noteworthy to realize this things first that this is perpendicular. So at this point, this is perpendicular. So if this is perpendicular, you can have the gradient of the line. Right. So in other words, we note first things first that the gradient times the gradient is -1. Obviously, it is LQ is perpendicular to NS. What is LQ? The gradient of LQ. What is NS? It is 2. Um, so now you therefore have therefore now you want the equation of LQ. So the equation of LQ is found as follows. So you say y minus y1, which is exactly m into x minus x1, right, which is y minus. What is y1? Right, so we are looking at LQ now. So you can take this one to be x1, y1, right? So if we have that, what is y1? It is -8. The gradient is -1/2. X1 is 4, right? So this one is -half x plus 2 -8 -6. Hey, -half x -6. So that is the answer. So we also show that is -1/2 x -6, and we have shown that for the 3 marks there. Right, the next question is we need to determine the equation of a circle having a center O, and O is the origin with the coordinates 0 and 0. Okay, center O, the origin, and also passing through S. Okay, so in other words, there's a circle that is centered at O passing through S. Just pretty much like that. Okay, this is not a perfect circle, but yeah. So what is the equation? First things first, you need to realize that that is very, very straightforward up there. So you'd have to do 3.4. So if it passes through that, you'd have x minus 0 squared. X minus 0 squared. Right, so you have x minus 0. So you'd have x minus 0 and then you square that. So it should be x minus 0 squared, and then you'd have y minus 0 squared is equal to. So now you continue and realize that the distance is like the radius. The distance from the center to that is actually a distance of 16 units. 16 units. So it is 16 squared. So what is the answer to this? 256. So the equation is x squared plus y squared is actually 256. So that is the equation. Then now we have done up to 3.4, but let's continue and do 3.5. Right. So in 3.5, we shall have exactly that one. Right. We're interested in finding the coordinates of t. Right. So in finding the coordinates of t, right, let's just clean up the diagram there a little bit so that we have a tidy diagram to deal with. Right, so we have solved this, and now let's just continue and clean up our board. Right, so our whiteboard, we're cleaning up our whiteboard so that we can continue. Right, we are doing more of this, and we're solving, obviously, more questions here. We are solving more questions here. Right, so now we are going to do something else. Right, so in continuing, we are looking at the next one, 3 point what? 3.5. I've read the coordinates of t. Okay, t is this one. T is exactly the equation. It's exactly the y-intercept of Rm. But we know the coordinates of m. We got them before, and we found the coordinates of m to be 6 and minus 4. And so now to find the equation, but also you can see that these two lines are parallel. So now we can be able to see, and we can tell, therefore, that the gradient of MR must be equal to the gradient of LQ. And we found the gradient of LQ to be what? To be minus 1/2. Why are these two lines, MR and LQ, having equal gradients? Because MR is parallel to LQ. Hey. Now what to find the coordinates of T? Which therefore means that we can therefore be in a position to determine. Therefore, we can be in a position to determine what we want. We can be able to determine the equation of the coordinates of t. Right, so to find the coordinates of t, we proceed as follows. So to find the coordinates of t, first we find the equation. So you can use y minus y1 is equal to m into x minus x1. So which means it's y minus, so it passing through m with coordinates 6 minus 4. So you have that. And therefore this is minus that x minus. X1 is 6. So it's minus a half x plus 3 plus 6. And therefore this is minus 1/2 x. Minus 1/2 x. The x must be same line, please. Okay, so we have 1/2 x. So that would be y equals minus 1/2 x plus 9. Okay. Let's see now. There is a small typo here. There's a small typo. Right, obviously the coordinates are those, but need to do is correct substitution here. X and Y were switched around. So first we do the y. Okay. So the y is minus 4 here at m. This is like x1, y1. And then the x1 is actually 6. So this is y equals minus 1/2 plus 3 plus 4 minus 4 minus 1. So now at this point, you're going to find the y-intercept. Right, so to find the y-intercept, how do you find that one? Right, so the y-intercept, to find it, you let x be 0. And x is 0, so you have y equals to minus half minus 1, which is minus 1. So which means, therefore, that t will have coordinates x 0 and y minus 1. So those are the coordinates of t. X is 0, y is minus 1. Okay. Right, the next thing is to determine the ratio in 3.6. Determine the ratio of RS to LS to RS. Right, so we're gonna do 3.6 now. Determine the ratio in 3.6. We proceed as follows. So first things first, we realize therefore that t will have coordinate 0, minus 1. We saw that here. P. What are the coordinates of P? Well, we've already found the equation of LQ, and therefore the coordinates, you just make x 0 here so that you have 0 minus 6. That is P, and then we also have S. 0 minus 16. The conclusion, therefore, is from these coordinates, is that PS is what? The conclusion, therefore, is that PS is 10 units. From minus 6 to that. The conclusion is therefore that PS is actually 10 units. PS is equal to what? Here is T and here is S. Well, the coordinates here are 0, minus 1 of T. So you can see therefore that the distance there is actually 15 units from minus 1 to minus 16. From minus 1 to minus 16. The distance is 15 units. Now, it means therefore we can find LS over RS. What is LS over RS? Right, so it means therefore that LS is equal to what? What is LS? LS is equal to PS over TS over TS. What is P? Okay, let's look at this is the proportionality theorem. This is called the proportionality theorem. The proportionality theorem. So what is PS? Okay, we continue. Right, what is PS? Okay, obviously we're looking at LS, L, S over R, S. Okay, let me clean this up because it's very untidy now. Right, if I'm to remove all these things here that are making a huge mass, huge mass. LS is this one? Right, so we have that. Right, so if you say, um, clean this up, I'm effectively looking at the fact that if you have LS and then you have RS, right, it's equal to PS, PS over PS over PS. Effectively, I mean, if you look at PS over TS, what is the answer? Right, we have already seen, we found the coordinates of P. What were the coordinates? And we found the coordinates of T. What are the coordinates of T? Coordinates of T were 0, -1. And then the coordinates of P were what? Coordinates of P were 0, -6. So which means now, if you look at PS, right, so it's like 10 units, okay? We've already said above is 10 units here. And then TS is 15. If you simplify this one, is what? 5 goes how many times into 10? 5 goes 2 times into 10, and it goes 3 times into 15. So which means, therefore, what they want is LS over RS, which is T over 3 units there. Okay, right. So we continue. We continue. And then now we're going to look at the next one. The next question. Okay, we're going to look at the next question. And the next question is just very similar to this one. Want to calculate the area of triangle PTMQ? Almost Pietermaritzburg. Okay, it's a town in the KZN there. Okay, so let's continue and do this one. So I will clean this up. Okay, continue. So now you have this one. Okay, we're looking at 3.7. Let me clean this up as well. 3.7, so these are removed. Right, so in 3.7, we're going to look at the area of triangle of triangle PTMQ. Let's see. Here is P. Here is T. And M. Q. The area of PTMQ. Okay, this obviously a shape that is like this is called a trapezium. Called the trapezium. So you have this and that, and then you have this and that. 3.7. So the area of PTMQ is the same as what? Right, so the area of PTMQ is basically a trapezium. We can find the area of the trapezium, or you can say the area of PTMQ is equal to the area of triangle TSM minus the area of triangle PSQ. Right, which is easier. The area of triangle TSM minus the area of triangle PSQ. What is the area of triangle TSM? Yes, please. Half. All right, just a few minutes, please. Right, so the area of triangle TSM is half the base ST multiplied by the perpendicular height multiplied by the perpendicular height through M. So that is the area of triangle TSM, because the area of triangle TSM is half the base ST multiplied by the perpendicular height through M. Okay. But also we have here minus the area minus half PS times the perpendicular height through Q. So this is the same as half. What is the length of ST? Right, you can see that we have 0 minus 1, we have 0 minus 16. So the base is 15. And then the perpendicular height is what? Is the perpendicular height is exactly 6 units. The perpendicular height is exactly 6 units, because you remember that this is 6 minus 4 in coordinate terms. The coordinates of M are 6 and minus 4. So which means that for the perpendicular height through M, we'll take the 6 off the x coordinate minus 1/2 PS. PS. What is the length of PS? Okay, this is P and this is S, and therefore the length, okay, 0 minus 6, 10 units. And then the perpendicular height will be the x coordinate through q, 4 units. Okay. Multiplying this is going to give us exactly 45 minus 20. And this is 25 square units. Okay. Right, so the area is that. But obviously you can use the area of a trapezium method, so it's also very much okay. But yeah, this would be the area of PTMQ, which is exactly 25 square units. You can also use the area of a trapezium formula. Okay, so we are done with that one. And we proceed now to move to the next question. We look at question 4, which is next. Now, this one is about a circle diagram. Circle diagram, so let's move on now and do this one. Right at this point, we're looking at question 4, and we're looking at the solution to it. In the diagram, P has coordinates minus 3 and 4 is the center of the circle. V has coordinates k and 1, and W are the endpoints of a diameter. The circle intercepts the y-axis at B and C. BCVW is a cyclic quad. CV is produced to intersect the x-axis at T. Angle OTC is alpha. 4.1 now. The radius of the circle is the square root of 10 units. Calculate the value of K if point V is also to the right of point P. Calculate the value of K if point V is to the right of point P. Clearly show all calculations for 5 marks. Right, PV, we can see this is P and this is V. So in other words, PV equals R is the radius of the circle this. That is PV. Okay, is the radius of the circle, distance from the center to the circumference then. Right, so, but moreover, we can use the distance formula for this because we can say PV. We have the coordinates. So having the coordinates here would have this one here. It have therefore that this is the same here. So at P is x1, y1, and at V is x2, y2. So you have some coordinates. We remember the distance formula, it's there at the back of the metric paper. Its formula of the distance is x1, x2 minus x1 squared. And we have y2 minus y1 squared. But obviously you can do it the other way around. So this distance is the square root of 10. So using the x1 and x2 that are there, so you can see that x2 is like it's k minus x1, which is minus 3. Y2 is 1, y1 is 4. So you square both sides, so this is k plus 3. Okay, 1 minus 4 is minus 3 square root, it's 9. And you square both sides here, you get what? You'll get a 10. Right, obviously we remember that the method of squaring both sides is as follows. So if you square both sides, you put the square like this. Which means it's k plus 3, 1. At this point, you can realize, so this is like you can apply the square root both sides, and then you put plus or minus, apply the square root here. So which means it's k plus 3, plus or minus 1. K plus 3 is 1. Minus 2, or k is minus 4. Okay. All right. See what we're getting here. Yes. But obviously, because we agree that k is actually to the right, so you'd have to choose, and it can only be this one. So the conclusion, therefore, is that k is minus 2 only. But k is minus 2 only, and therefore we have to find the value of k. We have to calculate the value of k. So k is minus 2 only. We have to obviously here to clearly show all calculations, and we have shown the calculation k is minus 2 only. Okay. Now we continue to look at the next question. What is the next question? The next question is 4.2. The equation of the circle is given as this one. So the equation of the circle is given as x squared plus 6x plus y squared minus 8y plus 15 equals 0. Calculate the length of BC. Calculate the length of BC. How do we find the length of BC? How do we find the length of BC? Right, so continue now. We look at the next question. Here's the next question. Right, so we look at 4.2. It's next. Right, look at 4.2. Right, in looking at 4.2, we shall get these right. No doubts. Open 2. Okay. The equation of the second is given by that. Calculate the length of BC. First things first, we know that the equation of the second is given as follows. It is given as exactly x squared plus 6x plus y squared minus 8y plus 15 equals 0. So now, at this point, you will be interested in finding the y-intercepts. Okay, because the B and the C are the y-intercepts, how do you find the y-intercept? So you let x be equal to 0. x0, you have the square here. Okay. So, okay, so you do what? You factorize this. Right, so they're minus 5 and minus 3, which means y is 5 or y is 3. Y is 5 and y is 3. So ideally, therefore, that would mean that y is 5 at the one that is higher, meaning y is 5 at B and y is 3 at C, because C is at a lower position. So now we want BC, so now we find BC. So BC can be seen as the largest one, which is YB minus YC. What is YB? It is 5 minus 3, which is 2. So you have that BC is equal to 2 units. Right, so we did 4.2, and then the next thing is to look at 4.3.1. Right, if k is minus 2, calculate the size of alpha. The size of alpha. So we are in business. Right, so we continue. We clean up the board. We clean up this board and we look at the next one. Look at the next one. So now, 4.3. Right, so in view of 4.3.1, we're interested in calculating the value of the angle alpha, so we can find first the gradient of TC. So the gradient of TC is y2 minus y1 divided by x2 minus x1. So looking at TC, and we're interested in the gradient. We're interested in the gradient. So, but there's certain things we already know, like we know the coordinates of V, which are what? Which are minus 2 and 1. And then we also know the coordinates of
B.
C, right? Well done to you. Thank you so much. What are the coordinates of C? We saw them before.
3.
Yes, so there are 3. There's 3 at C. So that would be 0, 3. And obviously those of B, just to mention, 0, 5. So we're good. Meaning now we can find the gradient of, we want to find the value of alpha, so we can find the gradient of TC. So now we can call this one x1, y1 in any order, x2, y2. This order is symmetric. So y2 is 1 minus y1 is 3 divided by x2 is minus 2 minus x1 is 0, and therefore the answer is minus 3 over 2. Okay, but moving forward, so we found the gradient. After we found this gradient here, no, okay, in the numerator is not 3 because it is minus 2. Okay, 1 minus 3 is minus 2, and therefore if it is minus 2, then we have that the result is what? You can put the minus minus there. That's fine. So I want to put the minus minus there because at the top is minus 2, and that is minus, and therefore the result is 1. So which means therefore the tangent of alpha is 1. Well, you see, the reasons are that the gradient always equals to the tangent of the angle of inclination. So at this point, we say the gradient of TC is the tangent of alpha, which is 1. So, which means we can be able to find now the angle. So what is the angle alpha? So the angle alpha is the arctan of 1. You're using a calculator is 45 degrees, or using special triangles. If you don't want to write like this, you can write like, or you can write like alpha is arctan of 1. What is arctan of 1? It is exactly 45 degrees. Okay, so we are done. But there are many ways to do this question. But now we have found the angle alpha. The next thing is to find the value, the size of the angle, VWB. Angle VWB. Okay, that angle there. Okay. Right, so what is the size of that angle? So you can just use anything, geometry, anything in geometry to do this one here. Right, so we can see that right. So let's just move that one to that one. So let's just go to 4.3.2 now. Right. So we're looking at 4.3.2. Right. In 4.3.2, it's this one we're dealing with. Right. So it's an exterior angle of the cyclic quad, because it's cyclic quad here. It's a cyclic quad, but it has an exterior angle here. So the exterior angle of the cyclic quad equals the interior opposite angle. So it is equal to exactly this one and this one. Okay, note therefore that this one is 45 degrees. This one is 90 degrees because it's the angle between the x and y axis. Okay, the angles in the triangle must be, the sum must be 180. So isn't that angle there must be 45 degrees? This is very important for us because we're able to see that angle BCV is equal to what? What is angle BCV? Angle BCV is therefore this angle BCV. Or you can say angle TCO, the easiest one. So we can do angle TCO. Angle TCO, this is TCO, is equal to what? This angle is equal to that one. So it's a cyclic quad. So the exterior angle, so with first, this one is 45 degrees. So you can start by saying TCO is 45 degrees. Why is TCO 45 degrees? It is a sum of the angles of triangle. Okay, if TCO is 45 degrees, then you can see that this is an exterior angle of a cyclic quad equals the interior opposite angle. So VWB. VWB yes, VWB. So VWB is equal to 45 degrees. Well, the reason for this is that you are dealing with the exterior angle of cyclic quad. The reason for that is that you are dealing with the exterior angle of cyclic quad because the exterior angle of cyclic quad equals the interior opposite angle. The exterior angle of cyclic quad equals the interior opposite angle. So this has led us to the conclusion that angle BWB equals 45 degrees. Equals 45 degrees. Right, the next thing we're going to do is to do 4.4 now. Is to do 4.4. Okay? Yes, Bopilo.
Not,
Yes, I'm gonna be saying you, Bopilo, but yeah, I'm having Sanulo with this other student online. Okay. Please stick around there, Bopilo. There are two chairs. Yeah, I'll come there, but I'm still online now. Okay. I'll come there, Bopilo, but I'm still online now. Because I'm with Sanulo and this other student. Right, so we're dealing with 4.4, 4.4.1. Right, a new circle is obtained when the given circle is reflected about the line y equals 1. Okay, I need to clean this diagram because it's so untidy now. Yes, Pupilo, please stick around there, okay? Please stick around there, Pupilo. I'm gonna come there to Tsenulo. But now please stick around because I know that it just came now. Okay, so we're looking at 4.4.1. Right, we want to find, yeah, a new circle is obtained when the given circle is reflected about the line y equals 1. A new circle is obtained when the given circle is reflected about the line y equals 1. Okay, so here is x and y. So a reflection about the line y equals 1 is going to be this. The coordinates of, yeah. So now you need to determine the coordinates of Q, the center of the new circle. The coordinates of Q, the center of the new circle. Right, so let's find the coordinates of Q, the center of the new circle in 4.4.1. Right, so what are the coordinates of this circle? They are minus 3, 1. Okay, they're minus 3, 4. Minus 3, 4. So, which means the coordinates of Q, the center of the new circle, If you reflect about the line y equals 1, will become what? Right. So you realize something, that what is going to happen is you have this one, or it's going to be reflected straight down. It's going to be reflected straight down like this. So this one is there and this one is there. And then that's exactly the same distance, same length, and so on. Okay, this is called an isometry. Isometry refers to the kind of transformation that retains distances. So which means that the coordinates of Q here will be, so the coordinate of Q would mean X is the same thing.
Right.
Yes, please, Pupilo. Yes, straight. Kalamanzi, you want to drink water? Okay, open the fridge. There's a glass there. Are you scared?
Come and open the Yes.
All right, I'm still online. Okay, Chanulo saw that I opened the fridge and I picked a glass from the top and I made juice for Chanulo. So please just, yes, but just that I'm still online now. You want me to come there? Okay, just give me like 5 minutes because I'm still online. Are you in a hurry?
Yes.
Are you rushing?
Yes.
Okay, let me talk to you then. Because I wanted you to get water for yourself.
So why you still
No, just that I'm having some with line. That is my student. Just in the student will come now. Just get some. You can't get the water. Please come get the water. I mean the studio. I'm having somebody from people.
I'm going. I'll see you on Tuesday. Tomorrow.
Serious?
And I'll come say and the people friends and tell you not online.
You don't like online?
No. Also on a face to face.
Yeah. You don't like online?
I don't
Okay,
understand.
I speak.
Ice cube. I don't know if they made the cube. And they here, come see.
Chairman's a preach again.
Yeah, please. Yeah, yeah, the ice cube. Okay, that's fine. You can put down. Okay, can I put the cube there and put the vacuum coming?
Yo.
Okay, I'm right back now. I'm continuing with the discussion. Apologies there because I know that you don't know what's going on. Somebody asked me to give them water.
No problem, sir.
All right, thank you. Right, so if you have the coordinates of Q there, this is Q. So obviously this reflection is therefore going to be at -3 because it's reflected straight down, and this is up here. So X is the same. X and Y. X is the same, but yeah. And then also the distance of Y will be maintained. So in other words, Y is going to be somewhere there, but the same distance. So what is the distance of Y from here? From here to there, because Y is 1 here, and then Y is 4 here. So this distance is 3 units. Okay. This distance is 3 units. So that going down will have to be 3 units as well. If it is 3 units, this one is 1, so this one is going to be at -2. So The coordinates of Q will have to be -3, -2. Okay. Right, so that is 441. Right, so you have 442. Okay, we found the coordinates of Q, the center of the new circle. Now, the equation of the new circle in the form this one. Right, so the equation of the circle of the new circle in this form, you have 442. Right, so the equation of the new circle in this form. So obviously the circle is the formula. You can write it as x minus a squared. And then you have y minus b squared. That is the formula. It's there at the back of the metric paper. And this is r squared. So you can see this one as your a and b. So this is x minus into -3. You square this one. And then this one is y. The b is -2. And you square these. It is equal to r squared. What is the r now? Let's just determine that one. Right, so you have r. Okay, r it's gonna be the same. So this is gonna be, remember the r is the radius of the circle. Here is a square root of 10. So this is gonna be a square root of 10, and then you square this one. Y plus 2, it's 10. So this is x plus 3, y plus 2 equals 10. The equation of the new circle in the form, this one, and it is 2. Right, so we continue. We look at 443 now. Right, so 443 is similar. Right, so 443 is similar. So let's look at 443. Right, so 443 now, the equation of the lines, drawn parallel to the y-axis, passing through the points of intersection of the two circles. All right, continue. Okay. Right. Okay. So 443 now is to do with this one, the equations of the lines. The equations of the lines drawn parallel to the y-axis and passing through the point of intersection of the two circles. Right, so these two circles will intersect. Okay, right. Right, right. So these two circles will intersect. So when these two circles intersect, you'd have this other circle that is going to have its own center, and also it's going to intersect the other circle there. Okay, it's gonna intersect somewhere. Can it determine exactly where it passes? Okay. Um, when it comes back, so right, right. So we can do that. The equations of the lines drawn parallel to the y-axis and passing through the points of intersection of the two circles. Right. So right, you can get that. Sure. Obviously, we note therefore a couple of things. What are the x values? So you'd have that x plus 3 squared y plus 2 squared equals 10. This is for circle. The one above is for circle Q. And then there's another one, x plus 3 for circle P. So you equate these two, which means x plus 3 okay. Okay, so you have this. This one cancels when these two circles intersect. So you have y plus 2. You square that, you have y minus 4. And you square that. Oh, this is a difference of 2 squares. So this is going to be y plus 2 minus that. Y plus 2 plus that equals 0. So now you have the first. So this one here is going to have y minus y 0. And then you're going to be left with 2 minus 4. So which means that you have 2y, 2 minus 4 is minus 2. 2 here. Y is 1. Right, so if y is 1, so they intersected y equals 1, these two circles, they will intersect somehow at y equals 1. So this is going to cut some here. If they intersect at y equals 1, then what are the x values? Let's check. So I erase this one. And I continue to solve. Okay, look at this particular question. We're able to see interesting patterns of reasoning. Right, interesting patterns of reasoning. So we have that we have seen that the intersect on y equals 1. Right, so using any of the equations of the circle, you can get the corresponding x values, or you can say using either, okay, using circle Q or, okay, let's use circle P. Why circle P? Because circle P was the given circle. It was given to us. And now if you use circle P, you'd have x plus 3 squared, y minus 4 squared, was 10. But y equals 1, so this is x plus 3. You square this. X plus 3. Then minus 9. Okay, so we have this. Hey. So at this point, you can look at this in two ways. You can look at this as a difference of two squares. So it's x plus 3 squared minus the number 1 squared. Difference of two squares. So if you have a squared minus b squared, is a minus b into a plus b. So this one is x plus 3 minus 1 into x plus 3 plus 1 equals 0. X plus 2, x plus 4 equals 0. X minus 2 or x minus 4. Okay, so those are the two values. If the question had said, um, determine the equations of the lines drawn parallel to the y-axis passing through the points of intersection of the two circles. They're parallel to the y-axis. So in other words, there's one line that is going to cut through here, and that will be x equal to minus 4, but this line is parallel to the y-axis. There is another line that's going to cut through there, which is x equals minus 2. It's going to be parallel to the y-axis. Okay. So we're done now. And these are the two results. The two equations of the lines. X equal to minus 2. And the other one is x equal to minus 4. Right, look at the next question. Question 5. Right, so here we need to simplify. Simplify the expression to a single trigonometric term. This one, 5.1. The tangent of minus x cosine x, the sine of x minus 180 degrees. Okay, the tangent of minus x, we say the negative angle x is in the fourth quadrant and the tan is negative. We discussed this. Okay, so we have this one. So what do we get? And therefore, this one is times cosine x. In which quadrant is x minus 180? Or x minus 180 is minus 180 the negative angle, or the negative angle minus 180, and the x, you can imagine x is a positive acute angle. So this here is actually in which quadrant? Let's just discuss this. Let's remember this, we did this. Right, dealing with the negative angles, we start here and say 0 degrees. Okay, the normal way is 90, 180, 270, 360. This is minus 90, minus 180, minus 270, minus 360. Oh, with this, if you then say cross the positive angles, cross them out. So you would say minus 180, x minus that, minus x minus 180. Okay, minus 180 is this one. But if you put an x that is like positive, a positive acute angle, the minus 180 goes back because we're moving in this direction. 0 minus 90 minus 180 and so on. So if you put a positive acute angle x, you're going back to minus 90. But if you say minus 180, you get an angle that's closer to minus 270. In the same way, you can say here, so yeah, I'm interested in this one. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So the x minus 180 is in quadrant what? Is in quadrant 3, and there the sign is negative. Negative sine x minus 1. Minus 10x. Oh, we can change the tangent to sine and cosine. Sine x over cosine x. Cosine x. Sine x. Negative. So cosine cancels out. You multiply the minus sign, and what you're getting is the sine squared of x minus 1. So this one you can factor out negative. And then have 1 minus the trigonometric sine squared of x. But you remember that sine squared x plus cosine squared x is 1, which means cosine squared x is 1 minus sine squared x. So in other words, 1 minus sine squared is cosine squared. So this is minus cosine squared x. So this is the answer. This is the answer. 5 marks. Okay, we continue. We continue. Right, so the next thing we're going to do now is look at question 5.2. You need to get all those. 5.1 has been done. And we're good. So 5.2 is straightforward. Okay, so we start as follows. We start by looking at this one, which is the cosine of 200 and what? 15 degrees. Which is the cosine of, you can use 180 degrees, 180 degrees plus 35. 35 degrees. Right, in which quadrant is 180 plus? 180 plus is in the third quadrant. In the third quadrant, the cosine is what? Negative. Cosine 35 degrees. Okay, cosine 35 degrees they've given us is m. So this is minus m. So which therefore means the cosine of 215 degrees is minus m. Then look at the sine of 20. Well, 5.2.2. The sine of 20. The sine of 20. Let's look at the sine of 20. Well, a couple of ways to think about this one. But if you look at 5.2.2, the trigonometric sine of 20 degrees is always equal to the cosine, because if 20 is an acute angle, is always equal to the complementary angle. That's complementary to the 20 degrees, and then that is 70. Because 20 and 70 is what? Is 90 degrees, so they're called complementary angles, and the sine of 20 is equal to the cosine of 70, because 20 plus 70 is 90 degrees, and these are complementary angles. Complementary angles. So, which means cosine of 70 which is cosine of 2 that. Okay,
Sir,
you know, yes, please.
5.1. You see 5.1?
Yes, I can see 5.1, uh-huh.
The answer is wrong.
Okay. What should the answer be?
The answer is supposed to be sine x times, I think, minus sine x
Okay,
to
let me
the
go back.
power.
Let me go back. Okay, please, let me see. Okay, let me go back. I'll get back to this one. I'll go back to it. That's fine. I'll look at it. It's there on the video, so you're gonna watch it. But yeah, let me see what we're talking about. Let's do it again. Let's see what you have there. That's 5.1, right? 5.1 is the
Yes, sir.
tan of minus x, cosine x, the sine of x minus 180 degrees, minus 1. Well, I was saying that the negative angles minus x is in the fourth quadrant. In the fourth quadrant, the tan is negative. I want to see if, right, so, and then obviously you have cosine x. I said x minus 180 is in the what? Is in the third quadrant. In the third quadrant, the sign is negative. Minus 1. Right, so we have minus the 10. The 10 is a trigonometric sine over the cosine of x. Cosine x minus sine x minus 1. Okay, let's check this one. Okay, cosine cancels out and we multiply this minus sine and that gives us what? Sine squared x minus 1. Okay, we pull out negative and we have minus sine squared x. A couple of things you need to remember here, that sine squared x plus cosine squared x is 1. Okay, this is called the squares identity. Okay, the squares identity. Or you can call it the Pythagorean identity. Pythagorean identity. So now we can want to make it like have the one in the sine squared on one side. So we can have cosine squared, which is 1 minus sine squared. What is 1 minus sine squared? It's cosine squared. So the answer is this. Okay.
Okay.
Any comment on that one?
Yeah, I know, so it's fine.
Okay, thank you. Wanted to make sure that we agree. Okay.
And I say,
Yes.
there's a problem, sir.
What is the problem?
My phone.
The battery.
It's gonna go out now. Yes.
All right. Do you use what kind of charger do you use? You use C something, C type.
Yeah.
Okay, I'm gonna give you a charger now. Okay. Okay, I'm
Make
bringing a
it quick,
charger.
sir. Escom is gonna go. 1
Alright,
hour
I'm
now. Escom is gone. Make it quick.
Okay, we're right back now. We're right back now. So please just note that we continue where we left off. Right, we have things.
Sir,
Yes, please.
why couldn't I have written cos squared x straight after the sine squared x minus 1?
That's a good question. I actually thought as much that students would think that way. And that's the reason why I actually went to this identity here. What does this identity say? The one I've put in the, it says sine squared, right? Sine squared x plus cosine squared is 1. Okay, if we make cosine squared the subject, what do we get? So we move the sine squared to the other side. So it becomes cosine squared is equal to 1 minus sine squared. Do you agree?
Yes. So sine squared x minus 1 is not the same thing as 1 minus sine squared x.
Yeah, that's the thing. So they're not equal. So in other words, that is why what I did here was to factor out a what? A negative. So that when I have sine squared x minus 1, because we want it to be 1 minus, because it's only when we have 1 minus sine squared that it is equal to cosine squared. It's only when the 1 comes first. Because it looks like they look similar to each other because they are sine squared and 1. So a student can be like, okay, it's just sine squared and 1, and then I can just put cosine squared. But obviously, in view of the fact that in principle, I know students have that temptation, okay, because, yeah, but now first we must say, what is the identity? It is cosine squared plus what? The identity is cosine squared plus sine squared. So it is cosine squared plus sine squared, which is 1. So we can make cosine squared the subject, which is cosine squared equals 1 minus sine squared. So it is only 1 minus sine squared where the 1 comes first, that we have cosine squared. But obviously in the thing we got in green, it was sine squared first. So we had to make sure we have 1 first. And we had to make sure the 1 is positive. How could we make minus 1 a positive? So we factor out a negative so that this negative now goes out. And when it is factored out, this negative, we have a negative into 1 minus sine squared. And then now we have 1 minus sine squared. And 1 minus sine squared is equal to what? Is cosine squared. But there's just a negative there. Okay, just note that because, yeah.
Thank you.
All right, that's fine. Right, the next thing is we're going to do 5.2.2, right? So because 5.2.1 we've already got. 5.2.1 was obtained with ease. The couple of reasons to note 5.2.1. Okay, we discussed that one. And just recap because we went back. Because it's cosine of 215 degrees. So 215 is 180 plus 35. In each quadrant is 180 plus 35. Okay, it is in the third quadrant. And if you look at the cast rule, okay, we're able to see that in the third quadrant is only 10 that is there. This is the first, the second, the third, and the fourth. In the third quadrant, it's only 10 that is there. So the cosine is what? Is negative. Right, and then we just copy cosine in the 35 degrees. Right, what is cosine 35 in the question was given? Cosine 35 in the question. Right, so we can see that cosine 35 is equal to what? We can see therefore that cosine 35 is m. So which means that in the place of cosine 35 can put m, so it is minus m. So cosine 215 is just minus m. Okay, we move on to 5.2.2, which is what I was doing. Okay, so there are billions of ways to do 5.2.2, like lots of ways to do that. But we're gonna just be good at it. So we're gonna use a method and see what we get. Right, so we have the following thing. We have the following thing. We have the following. Right, so let's see what we have. Right, so let's look at this one. 5.2 something. All right, 5.2.2. We have the sine. Here is 5.2, sine of 20 degrees. So we have the sine of 20 degrees. Sine 20 can be seen as, we can change sine to cosine provided we put the complementary angle that it can be added to 20 to get 90 degrees. So obviously this is true because of complementary angles. Complementary angles. Right, so this is cosine 70. But cosine 70 is the same as 2 times 35. So if you have cosine 2x is 2 cosine squared x minus 1. Okay, is a double angle formula. So this is 2 cosine. I'll just put the x there, but right. So the x is like 35 degrees. Okay. What is 35? What is cosine 35? Cosine 35 is exactly m squared minus 1. So which means we have sine 20. Sine 20 is twice m squared minus 1. Sine 20 is twice m squared minus 1. Sine 20 is twice m squared minus 1. We look at 5.3. Determine the general solution of this one. Okay. Determine the general solution of that. We move on to 5.3. 5.3. So we're down at 5.2.2. Right, moving on to 5.3, we have the following. We have the following. Right, so let's move to 5 point. Let's move to 5.3. 5.3. All right, 5.3 would have cosine for x. Cosine x, sine x, the sine of 4x is minus 0.7. Okay, so this is like a compound angle formula. We know something, that the cosine of a minus b is cosine a cosine b minus sine a sine b. So this is going to be cosine of a minus b, which means it is 4x minus x equals minus 0.7. Which means, therefore, you have here the cosine of 3x equals minus 0.7. Right, so we're going to find something called the reference angle. But the reference angle of this is arc cosine of the positive, 0.7. And the answer here is 45 decimal comma 57 degrees. Okay. First things first. The cast rule is clear on this. So we have that this is called the cast rule. And therefore, cosine is negative. In which quadrants is cosine negative? We know that cosine is negative in the couple of quadrants like the second and the third. Okay, it is positive in the first, and so this is the first quadrant, the second, the third, and the fourth. So we're going to deal with the two quadrants where it is negative in the second and the third. So which means 3x is equal to 180 degrees minus 45.57 plus 360 degrees times k, where k is in the integers. This is going to take us to the second quadrant. 180 minus is in the second quadrant. So this one we're dealing with here is quadrant 2. If we subtract this, it means 3x is 180 minus that, which is 134.43 degrees plus k times 360 degrees, where k is in z. So x is 44.81 degrees. If you divide the 360 by 3, you get 120. So this is k by 120 degrees. K is in the integers. Okay, there is an alternative answer, obviously, to this one. We also have the following. Right, so we have the next one. So this is going to be 3x. The 3x is coming from here. Cosine 3x is 0.75. So it's 3x equals now 180 degrees. Now we are using the reference angle, but we're putting ourselves in the third quadrant, so it's a plus. So this is quadrant 3. So you're putting plus 45. Comma 57. Plus k times 360. Which means 3x is 225. Divide by 3. So if you divide by 3, it becomes 75, 19, 120 degrees. K is an element of the set of integers. Hey. So the question obviously in 5.3 has been the general solution, and therefore we have found the general solution. Okay. So we found the general solution in 5.3, and the general solution is given by those two parts there in blue, in the blue color. The next thing now is to continue and do more of this, but with a specific focus on 5.4. 5.4. Right, so in 5.4, we I want to prove the identity. So we're going to proceed to prove the identity. Let's remove 5.3. We're done with it. Okay, we're done with it. Okay, we're done with it. So we continue. So we're looking at 5.4 now. Right, we want to prove the identity, the trigonometric sine of 4x cosine 2x cosine 4x, the sine of x, cosine x, which is divided by the tangent of 2x. Tangent of 2x. Right, the tangent of 2x. Which means you have the left. So the left-hand side is this. Sine for x. So in other words, you can start by saying the solution you let the left-hand side be sine for x cosine 2x minus t cosine for x sine x. So cosine x you divide by the tangent of 2x. Right, so this is sine 4x cosine 2x minus cosine 4x 2 sine x cosine x. So I just pushed in the 2 into the brackets. And then we have sine 4x cosine 2x cosine 4x, and then 2 sine x cosine x is sine 2x divided by 2. Okay, because that's what we have. Okay, so now we have this, and this is exactly the thing. This is exactly a trigonometric sine of 4x minus 2x. It is actually divided by 10 to x. So we actually have here tangent of 2x. Tangent of 2x. Which is the sine of 2x divided by the 10 of 2x. Okay, now let's look at this. Okay, so you have the sine of 2x over cosine 2x. So this is sine 2x. You multiply by, you reciprocate cosine 2x divided by is sine 2x. Okay, right. So which is the right hand side now? Okay, not yet the right hand side. Not yet the right hand side, because the right hand side has what? This is the right hand side here. The right hand side is having a couple of things. It has, is this one? It's cosine squared minus sine squared. Okay, but we know that cosine 2x at the back of the matric paper, there's a formula sheet, and the formula sheet says cosine 2x is cosine squared minus sine squared, and the examiner will realize that you know that, and this is actually the right hand side, cosine squared minus sine squared. So we have that the left hand side is equal to the right hand side. And done. And we are done. Right, we move to the next question. Question 6. Right, question 6 is a couple of parts, but obviously in the diagram, below the graphs of f and g are drawn for the interval minus 180 to 180. A and B are 2 points of intersection. Here is A and here is B, but there are 2 points of intersection of f and g. Without using a calculator, determine the values of x for which cosine 2x is equal to minus sine x in the interval, this one, 6.1. Let's look at this now. Right, so, determine the value without using calculator, values of x for which cosine equals this. So we have cosine equals this. So cosine is minus sine. So this is 1 minus 2 sine squared. Okay, this is an identity that says cosine 2x is 1 minus 2 sine squared. It's an identity at the back of the metric paper. From this, we move the 2 sine squared, negative 2 sine squared to the other side. It becomes 2 sine squared. But on the right, it finds minus sine. You move the 1 to the right, it becomes negative. We open brackets. So we have 2, the sine of x, the sine of x. The signs will be plus 1 minus 1, which means sine x is minus 1/2, or sine x is 1. So the reference angle is always arc the trigonometric function of the positive 1/2. It's just negative 1/2 there, but write positive, and the arc sine is what here? The arc sine, let me write it at the bottom, is 30 degrees. So if this arc sine 1 is 90 degrees. These are the reference angles. So we can see therefore here that the sign is negative. Where is the sign negative? Cast diagram. Okay, the sign is negative, is positive in the first and the second quadrants, but it's negative in the other quadrant. So the sign is negative in the third, but it's also negative in the fourth. So we're gonna get to those angles there. So how do we get that? So which means x is right. So we're gonna do 180 degrees plus 30 degrees plus the period of the sine is 360 degrees times k, where k is an element of the set of integers, 210 degrees, 360 degrees. Okay, 210. Oh yes. We have the following. This was 180 plus in the third, and then the other one is actually in the other one, yeah, in the fourth. So now what is this? So that will be 360. We subtract 360, we subtract 30 degrees. 360 times k, where k is an element of the set of integers. 330. K is in the integers, which is 330. Okay, so now this is what we get. So for the reference angle of 90, we infer that x is 90 degrees. K times 360. There's an element of the set of integers. Okay. So this is a solution to, well, these are the values, because it's to determine the values of x. These are the values of x for which the two equations are equal. Okay, but these are general solutions. So we need to continue and simplify these because we need specific values. So we continue. What are the specific values? Minus 150. Minus 30. Or x is 90. Okay, well, look at the solutions between minus 180 and 180. So obviously here, when k equals 0, we have x equal to 90. So here, when we have k equal to minus 1, you put k equal to minus 1 here, where you have 210 plus 360 by k. So you put k equal to minus 1 is going to be minus 360 plus 210, which is minus 150. Right. You come to the last equation. When k equals -1, you substitute everything, which is minus 30 degrees. Okay, minus 30 degrees therefore puts us where? At minus 30 degrees is one of those. So in other words, you'd have here minus 30. Minus 30 degrees, minus 150 degrees, 90 degrees. 90 degrees. So those are the three angles there. And with that, we have scooped and obtained the 6 marks, getting closer to getting our distinction damage check paper. Now we move to 6.2, then 6.2.1. Use the graphs above to answer the following questions. How many degrees apart are points A and B from each other for 2 marks? How many degrees apart are points A and B for 2 marks? Very, very easy. Right, so to do that one, we'll find AB. So that's going to be how many degrees apart? So you can just say minus 30 degrees minus into minus 150 degrees. And this is 120 degrees. 120 degrees. So the points A and B are 120 degrees apart from each other. Okay, so move on. Okay, we're looking at 6.2.1 and then we're looking at 6.2 now. 6.2.1, 6.1. Point 2.2. For which values of x in the interval will f primed just times g primed be strictly greater than 0 for 2 marks? So this has to do with positive slopes. So you have a positive slope, positive times positive gives a positive. Negative times negative gives a positive. So 6.2.2. Okay, so in 6.2.2 now, let's do this one. The slopes must be the same. So you can see that between 0 degrees and 90, the slopes are negative. Up to here. So which means, therefore, we choose x to be an element of the interval open from 0 to 90 degrees. Between 0 and 90 degrees, the slopes are both negative. So you have negative and negative, which is positive. Or x is an element of the interval 90 and 180. Here, the slopes are both positive. Both functions are sloping up, so x is an element of the interval between 90 degrees and 180. 90 degrees and 180. They're both going up slope. Okay, if you want to say this like this, things like this, you can say 0, 90. 90, 0 to 90 or 90 to 180. 0 to 90 or 90 to 180. Okay. 6.2.2. Right, so we have this. So now we look at 6.2.3 now. Right, so in 6.2.3, determine the values of k for which this one will have no solution. So here we're looking at the cosine of double x. Which means it's k minus 3. So if the cosine is k minus 3 now, it would mean a couple of things, but it would mean we know a couple of things about this. So we know generally in mathematics that cosine 2x or just cosine x lies between minus 1 and 1. So lies between minus 1 less than cosine 2x less than 1. Hey. So which means, therefore, we shall have that the k minus 3 if you wanted to have no solution, so we take the k minus 3 to be less than minus 1, or you take the k minus 3 to be larger than 1, which means k is 2. Okay, k here. K is 4. K is less than 2, k is 4. K is less than 2 or K is 4? So you'd have no solution because the solutions are possible when we have that. When the cosine x lies between -1 and 1. Okay. Right, we continue now. We look at the next question. The next question is about the rules, the sine rule, the cosine rule, and so on. And then we just get that one discussed. Right, so we have that right, in question 7.1, points B, C, and E lie in the same horizontal plane. ABCD is a rectangular piece of board. CDE is a triangular piece of board having a right angle at C. Each piece of board is placed perpendicular to the horizontal plane and is joined along DC, as shown in the diagram. The angle of elevation the angle of elevation from E to D is X. DEC is 2X. EBC is 30 degrees. 7.1. Show that DC is BC over this. Show that DC is BC over that. For cosine squared X. So first we shall work in triangle. BCE. BCE. Right, so in this triangle, we shall say CE over the sine of the angle opposite. CE is this one. The angle opposite is going to be 30 degrees. It's equal to BC, this one, over the sine of the angle opposite BC, which is twice X. So which is CE is equal to BC. The trigonometric sine of 30, we divide everything by the sine of 2x. Okay. In triangle CDE, we have the tangent of DEC. The tangent of DEC. The tangent of DEC is equal to the opposite DC over the adjacent CE. We're interested in DC. Algebraic manipulations give that DC is CE, the tan of DEC. What is CE? Which is BC. The sine of 30 divided by the sine of 2x. And then you have the tangent of D is C, which is the tangent of X. Right, so what is all this? So this is exactly BC divided by. So what is sine 30? Sine 30 becomes 1/2. And then you have the 2 sine x cosine x from sine 2x. Sine 2x is 2 sine x cosine x. Then the tangent is the sine of x over cosine x. Sine cancels out, which is BC over 2 by 2 is 4 cosine squared x. That's the answer. So this is BC over 4 cosine squared x. So we have answered and we have shown that BC is 4 cosine squared x. If x now in 7.2 is 30 degrees, show that the area of A, B, C, D is 3. A, B, C, D is 3AB. A, B, C, D is that. Okay, so if you look at this one, we need the area of this. Let's erase 7.1. Right, so we're done with 7.1. We clean the board. And then we're moving on. We're moving on. So now we're looking at 7.2. So obviously at this point we have BC. BC is BC over 4 cosine squared. Or it is exactly BC over 4 cosine 30 degrees. Cosine 30 is the square root of 3 out of 2. Special triangles. Hey, simplifying everything here will just give us BC over 3. The conclusion, therefore, is that BC is 3DC, but AB is equal to DC. Opposite sides of a rectangle. So at the simultaneously able to see that BC is 3AB. BC is 3 AB because DC is equal to AB. So the area they want, the area of rectangle, is equal to AB BC. Is equal to AB BC. Okay. So if that is true, AB BC, what is AB? We're gonna have AB here. BC is 3AB, which is 3 AB. So we have to show that the area of ABCD is 3AB squared. And we have shown that for 7.2 for 3 marks there. Okay, the electricity is going to leave very soon. The electricity is going to leave at 4. So I must take a break now. And I can only return after 6. I can only return after 6. Okay. You hear me, guys? You hear me, Tenulo?
Yes, sir. No
Okay.
problem.
Yes. Okay. Thanks, Waruna. Right. I'm going to send a video during the course of the load shedding, I hope. But yeah, it's just a few minutes that I'm going to upload the video and then I'm going to send the video. But yeah, I can only be back like after 6 because now it's going to leave from 4 to 6. Okay. So thanks a lot,
Okay.
guys. I'll see you guys on the other side after 6. Okay. Thank you.
Thank you,
And
sir.
okay. And goodbye to you.